NumPy Arrays lecture. So, NumPy Module is short for Numerical Python. It's designed for high-level computation, can perform hundreds of methods and has multiple attributes, performs fast mathematical operations without loops. NumPy works with n-dimensional arrays. Arrays are usually 1D vectors and 2D matrices. NumPy arrays can also be 3D, 4D, etc. And NumPy arrays work only with homogeneous data, so integers, floats, strings. It can't work with a mixture of different types of data, so they all have to be the same. Okay, so we're going to hop on to Jupyter Notebook and carry on from there. In this lecture, we're going to compare an array to a list. Then we're going to compare the computational speed of an array to a list. And then we're going to be shaping and reshaping arrays. And then lastly, indexing and slicing arrays. So what you need to do is import the NumPy module as np. And if I were to do simply np.tab, you can see all of the available functions or methods and attributes that make up the NumPy module. And of course, it's in alphabetical order. So what you might be surprised to know is that there are actually over 600 methods and attributes that make up the NumPy module. So if you were to do dir, which is a built-in Python function, and do np, you get a list here. So you can just count them by simply doing len. And as you can see, we have over 600 methods and attributes. So of course, we're not going to be covering all of them, just the major ones. And the most important one for this particular lecture is the np.array. But at the moment, what we're going to do is simply create a list here. So num, and then list range 10, 60, 10. And then we'll do num. So as you can see here, we have a list from 10 to 50. And then we can actually convert this into an array. So we'll do vec for vector, np.array, and then num, and then vec. And as you can see, it's almost entirely the same, except that it has an array here with the parentheses. And I'm about to do simply .dtype. What you get is int32. And note this is an attribute, not a method or function, because it doesn't have the parentheses here. Okay, so of course it's an integer, as is the list as well. And if I were to do type vec, you get numpy.ndarray. And ndarray stands for n-dimensional arrays. So at the moment, what we have with our vector is a one-dimensional array because it only has the single square brackets on either ends. We'll be working with multiple dimensional arrays later on in this lecture. Okay, so scroll down here. Let's say I was to create a new one. So we'll do np.array. We'll have, let's say, 10, and let's say we do 12.4. If I run this, what you'll notice is that the output is only of floats. So initially our 10 was an integer, but it's been converted into a float. You notice the decimal point here. And what this means is essentially arrays in NumPy can only be homogeneous data. You can't have different types of data, like say for instance we have 10, which is an integer, and 12.4, which is a float. So it converts all of the data into floats. Okay, and likewise, if I were to do np.array, and then I do, let's say, 10 again, and we do, let's say, we have another one, and then I do, so we have integer, floats, and now we have a string. What you'll see is that all of them are converted into strings. And if I were to do simply dtype, you're going to get, of course, u32. Sometimes it's going to be u11, as you can see here. Okay, and also what you can do is, at the moment with this vec, which is the array with these integers, you can actually convert them all into floats or strings. So we do .asType, and this time it actually is a method or function, and we'll do, let's say, float 64, and you get float 64. And if I just go back here, just delete this, square brackets, then do dtype, you're going to get float 64. Okay, so that's where that comes from. And I can also do, let's say, u32. You can see we have strings here. I'll also do 11. You also get strings here too. Okay, so moving on from that, we can actually do some arithmetic on our array. But we can't really do that on a list. That's the important point to note when comparing a list to an array. So let's say we simply do num plus 10. You get an error. And if I were to do, let's say, times, this is the only one you can really do when it comes to multiplying a list. So what do you say 3? And you'll notice that it simply is repeating all of the elements 3 times. But if I were to do this with my vector, which is the array, times 3, what happens is that all the elements within the array are multiplied 3 times. So as you can see here, 10 is now 30 all the way to 150 instead. Okay, and I can also do, let's say, vec plus 100, or I could do vec minus, let's see, minus 23, or I could do vec, let's say, divided by 3, or you can do floor division as well, so you just get integers. And of course I can do raise to the power of, so raise to the power of 2. Okay, so that's pretty cool. And also, let's say for instance I did num plus num. So you can add lists together, of course. And if I did num again, you get the equivalent output above, which is what we have here with the num times 3. We'll just stick with 2 for the time being. And let's say I were to do print num and print vec, just to make a comparison here. I'll just scroll down here. We'll keep it in the same cell. And let's say I were to do num plus vec. So you can see that it simply added all the values together for each of the elements. And then I could simply do, let's say, num times vec. Okay, so it's simply 10 times 10 is 100, all the way to 50 times 50 is 2,500, and so on. Okay, so let's say I were to do vec times, or raise to the power of 2. So we had this value before initially when we were doing some arithmetic, and let's say if I wanted to recreate this particular output. So let's say I have vec2, and then I do vec2.toList. This doesn't take any parameters, and now you have a list here. Okay, so how am I going to recreate this particular output using a for loop? So we'll do simply case equals empty list, of course, then we'll have for I in range len, and then we'll do num, colon there, then res equals num, I, raise to the power of 2, then case dot append, res, and then case. So as you can see, we have the exact same output here, but it's with a total of 5 lines of code, which is quite lengthy compared to only 2 here. Okay, so let's say I were to do the same thing with list comprehension. So if I have num I for I, that's supposed to be raised to the power of 2, for I in range len num. And there you have it. So you might be wondering, what's the point in using a NumPy array when we can simply do it with a list comprehension, or if you want to go the long way, with a simple for loop? Well, the reason being is because of computational speed. So we can make a comparison here. We'll simply do val, and let's say we have list range, and we'll do 1, 2, let's say we have 1,000,001. So just check I've got 1 million here exactly. So we have 5, yep, that's fine, and then we'll do it by 1. Okay, and I'll simply do len val, we'll just check. Okay, so we have 1 million here. So we have 1 million integer values in our list. So we're going to change the num to a val. But before we do that, I'm going to put a time here. So we'll have a magic method called timeIt. And we'll talk about this in a future lecture, but for now, simply do 1, then minus, okay, so you have minus r1 minus n1. So normally if it was just time it without these here, without the minus 1, 1, minus n1, then it would repeat the loops more than once. We only want to do it once to make a comparison. Okay, and we'll change the num to a val as well as here. Okay, we'll just see how long it takes to run. So it took 1.33 seconds, which is pretty slow. Okay, then we'll do the same thing with our list comprehension here. So we'll swap the nums for val. And again, we're going to have the time it, and then we're minus r1 minus n1. Okay, so this took 1.21 seconds, so it's slightly faster than the for loop. Okay, so now we're going to do it with the vector, which is the array rather. And what I'm going to do is, so we have vec free equals, we'll have np.array val, and then we'll multiply that, and then I'll do vec free dots to list. But before I do that, of course, I don't want any output. I only want to know how long it takes to perform the actual task itself. So minus r1 minus n1, and that should do it. Okay, so that took only 237 milliseconds. So that's roughly about, say, 4.5 times, 5 times faster than a list comprehension. So it's significantly faster overall. So say you're dealing with gigabytes of data, and say, for instance, instead of it being, let's say, an hour, it was just 15 minutes or 10 minutes. So it's a lot faster overall. Okay, so that's the major reason why NumPy arrays are used compared to, say, lists or sets or dictionaries, etc. Okay, so moving on from that, let's say we wanted to create some arrays that are multidimensional. So let's say we do ran. We'll just have this as list range. We'll just do a normal range for the time being. 121, 2. We'll do ran. Okay, so we have a normal list here. We're using the list and range methods. And if I have to do, let's say, zoom equals np.arange, which is equivalent to what we have for the range, do 121, 2. And we'll do zoom. Okay, so it's exactly the same values here. But what's interesting about this is I could actually, of course, as you can probably imagine, I can multiply the values or add the values, etc. So I can do arithmetic on them just like I could with a normal array. And let's say, for instance, I wanted to, instead of it being integer values, I could do 0.5. Now, as you can see, it's incrementing by 0.5. You can't do that with the list range methods. Alright, so moving on from that, let's say I wanted to reshape my data. So I'll put this back to 2. So at the moment this is a one-dimensional array. Now you can actually reshape this, and you can use that by doing dot reshape. Now we have a total of 10 integer values in here, so I can do 5 by 2, and you get what is actually a n-dimensional array. So it's got 2 dimensions, and the reason why it's got 2 dimensions is because it has 2 square brackets on either end. Now, before I go into that, I just want you to bear in mind that I'm using 5 by 2. I can't say, for instance, do, say, 20 by 2. This is going to give me an error, a value error. Cannot reshape an array of size 10 into shape 22. The reason being is because I have 10 elements in the zoom array. So it can't go beyond that. So, for instance, 20 times 2 is 40. So what you'd have to do is 5 times 2, because 5 times 2 is, of course, 10. And if I do, let's say, 10 times 1, of course, is also 10. So that's acceptable. Okay. And if I do shape, you get 10 by 1. Okay. And if I to do, let's say, zoom.shape, you just get 10. Alright, so moving on from that, let's say I were to simply create a matrix. So I'll do mat, and I'll do np array, and we'll have 1, 2, 3, and then another list, another nested list. So we'll have 4, 5, 6, then 7, 8, 9. Okay. So we have here our matrix, so it's a two-dimensional array, and then we do simply ndim, which is just an attribute, you get 2. The reason why it's 2 is because you have these two square brackets here. So it's a two-dimensional array. And similarly, if I were to do with zoom, which is just a one-dimensional array, if I do ndim, whoops, that should be ndim, you get a one-dimensional array. Okay. So moving on from that, let's say I were to do an index. So you can index it. So if I do 2, for instance, you get 7, 8, and 9. So we'll just do mat here as well, just to make a comparison. So if I were to do 3, you're going to get an index error. Index error, as you can see, because it's outside of the range. Okay, so we'll do 2 again. Let's say, for instance, I wanted to change the value. So at the moment there's 7, 8, and 9, but I can actually reassign them. So I'm going to do, let's say, 10, 20, and 30. And then we'll do mat again. And as you can see, now they're 10, 20, and 30. Okay, I'll just run that again. Alright, so moving on from that, let's say I wanted to do 2 again, get 10, 20, and 30. And if I were to do, instead, we're going to do a slice notation this time. So with that, you can see they get 1, 2, 3, 4, 5, 6. So we're getting a subset of our array here. And if I were to do mats, and this time I want to get, instead of just being the rows, which is what we selected, we've only selected the rows here. What if I wanted to get the columns as well? So at the moment, this just is about selecting rows. So if I were to do, let's say, this is going to be for the rows. And now you can see I have this here. So it's cut out the 3, 6, and 30. Alright. And let's lastly try a couple more. So we'll do mat 1, 1, 3. We have 5, 6, 20, and 30. So we're grabbing only these values here. So 5, 6, 20, and 30. And lastly, we'll just do one more. That is 1, 2, and 1, 2. So this time I'm just going to grab the 5, as you can see here. So 1 and 2 is for the rows, so I'm grabbing 1 and 2. So 1 and 2 is just going to grab this row here. So to do this again, 1, 2. Okay, so just get this row. And then 1 and 2 again just grabs this particular number here. Okay, so that concludes my lecture on NumPy arrays. Hope that's been insightful. If you have any questions, feel free to ask in the Q&A. Thanks.